Hey guys, Danne here, and welcome to week 13 of creative coding. So in this week, we are going to be covering audio and p5.Sound library. So we're going to be playing around with audio and sounds in p5 by creating our own instruments, by triggering sounds, loading in sounds, playing around with oscillators. So we're also going to be doing FFT analysis on the audio files and doing visualizations around the audio that we're loading in. So real quick, I just want to talk about sound in general. So sound is basically just the vibration of air molecules around us, and the vibrations are going from point A to point B, so from like a dog barking to our ears. So all that vibration is just vibrating the air particles around us until it hits our eardrum. So that's how we could hear sound, and that's how we can produce sound. It's all about vibrations and the waves that it creates. So how does sound work? So basically we have an amplitude and a frequency. So the amplitude, the lower the amplitude, the smaller the amplitude, the quieter the sound is. The higher the amplitude on the wave, the louder it is. And for frequency or pitch, the longer distance between each wave is going to be a lower pitch, and the shorter distance between each sound wave is going to be a higher pitch. So I briefly mentioned that we're going to be doing FFT analysis, which stands for Fast Fourier Transform. And basically what that is going to do is just take the audio and transform it into data points, which we can then apply to like a line graph or a bar chart or any sort of visualization that we want to. So it's taking the audio, converting it to data, and then we could apply that data to a visualization of some kind. So there have been a lot of really beautiful audio visualizations done in the past. This is one of the original ones for the iTunes visualizer on Apple computers, which was originally created by Robert Hodgins, who is an amazing creative programmer and creative artist and technologist, and has done a lot of really interesting things with audio visualizations. So he did the original version of the visualizer for iTunes, but if you wanted to play around with visualization and see what you can produce with iTunes, there is two different versions in the current version of iTunes. There's the classic version, which is the one that Robert Hodgins had a hand in, and then there's a more modern version that is much more like three-dimensional and cosmic looking. So feel free to go to Apple's iTunes, play a song, and then open up the visualizer to visualize what you're listening to. So we are also going to play around with creating our own instruments using P5. Basically what that means is we are going to be loading in sounds files and sample sounds, and then we could trigger them on key press or mouse press or some sort of interaction. It's basically triggering sounds on key press and playing your keyboard like a piano. So why don't we check out a few examples? Let's go ahead and go to the class website. So if you go to creativecode.dannewoo.com, and then let's go to week 12 for audio. There's a few different things that we're going to play around with here, but the first thing I want to look at is just like helpful links. So there is a link to a more descriptive website around FFT analysis and what that actually is. There's a link to Robert Hodgins' website, so you can check out some of his work. And then there's some other projects that are audio related that would be of interest to you too. So one is a p5.Sound. Let's try that. So this is an instrument that's basically just triggering sounds on key press and applying some sort of visualization to those as well. So let's play around with the keyboard a little bit. So I'm just pressing ASF. But if you press any key on the keyboard, it's attached to a sound file and a visualization. So that's definitely fun to play around with. So I highly recommend that you guys check that out. You can record your creations as well and share them. It's a pretty great platform. So another great project is listening to Wikipedia. And this is pulling live Wikipedia data from their API. So whenever someone creates an entry on Wikipedia or a deletion, taking something off of Wikipedia, deleting it, or creating an account or logging in, those different actions get applied to different audio files and different strings and different horns and orchestral music. So I believe the white circles represent an entry, and I think the green circles represent a deletion. And then there's a purple circle that I believe is someone logging in. And then the strings here represent a new person joining Wikipedia. So that's a great piece that you should definitely check out. It's very relaxing just to have it playing in the background. It's also interactive, so if you click on any one of these circles, it's going to take you to the actual change on Wikipedia, which is pretty cool. Another person to look at is Alexander Chen. He does some amazing stuff with JavaScript and audio. So this project is called mta.me. And this is using MTA data to create this visualization, which is also an instrument. So each one of these lines is coming in and represents a different subway line on a subway train. And as the lines get closer and closer together and cross each other, they pluck each other as a string. So the longer the line, the deeper the sound. The shorter the line, the higher the pitch. So it's very much like the sound wave. So a wide sound wave is going to be a deeper sound versus a shorter sound wave is going to be a higher pitch. And it's interactive, so you can pluck these strings too, which is pretty great. And this is all JavaScript, just like P5, it's all JavaScript. So that's a really great project. And then there's some other projects around here. These are all physical projects, physical instruments. Beatbox is really great. This is a project I did called the RFID Beatbox. These last three are all my projects. The light hum is an instrument that converts light waves into audio waves. And this was actually my thesis project coming out of undergrad. It's an American Stringed Instruments site, which is done in Flash, so it's very out of date, but it's still worth checking out if you're interested. Great, so make sure you check those out. While we're on this page, why don't we go ahead and download some example audio files for us to play around with when we're actually getting into the code. So let's click that and download those audio files to the desktop. So let's go ahead and unzip that. Okay, so now we have audio files for us to play around with and these examples. So here's what we're going to cover today when it comes to P5. So we're going to be using the p5.Sound library, which is another library that's associated to the P5 library, but is its own separate library, meaning we have to link that to our HTML to get it to work. Luckily, if we're using the P5 web editor, which we are, that is already included in the HTML file. So we don't have to do anything to link this sound library to the HTML file since it's already there. For audio players, we're going to play around with some of these functions: load sound, play, pause, loop, and set volume. We're going to play around with audio input as well. There's a P5 audio in object that allows us to get audio in from a mic on our computer or an external mic that's hooked up to our computer. And some of the functions that work with that are connect, disconnect, and set input. Oscillator, we are going to play around with oscillators and playing around with frequency and amplitude to make our own sounds using frequency and amplitude and changing the values for each of those. And then we are also going to play around with FFT analysis, which is basically going to take the audio file, analyze it, break it into a data set, and then we can apply that data, those values, to a visualization of some kind. So that could be like a line wave or a bar chart or something more interesting and creative. So some of the functions that we're going to play around with that is analyze, linear averages, logarithmic averages, and waveform. So the first example we're going to play around with is just how do we get audio files loaded into our P5 sketch. So first we have to create a variable for our sound file, and we're going to use the preload function to load in the sound. And we have to set my sound, which is this variable we created, to be equal to load sound, and then pass in where that sound file lives. We're just going to be working with MP3s. You might be able to work with WAV files. I'm not sure. I haven't done that before, but feel free to experiment. And then in setup, we're just going to create our canvas and a background, and then we could say my sound.setVolume. The set volume value should be between 0 and 1. It's a decimal point. When it's 1, it's going to be full volume. When it's 0, it's going to be completely muted. And then we have to play the sound. So we have to reference the sound file that we are trying to play and then attach the play function to it. So let's go ahead and go to our editor. So editor.p5.Sound.org. Go ahead and log in and create a new sketch. So the first thing we need to do is upload some audio files to play around with. So let's go ahead and go to upload file. And I am just going to drag and drop. So I'm going to get out of full screen. And I am going to look for my audio files. And I'm going to do this Marcus Calise theme. Let's upload that. And then I'm going to upload a few sample audio files. These audio files were taken from Papatap. They have a GitHub account that where they share all their code and audio files for. So I'm just going to do the first 5 in the A folder and upload those as well. For whatever instrument we're going to play around with, we're going to use those files. Okay, so once it's all uploaded, so we should see all the files in our root directory, then we should be good to close this upload file window. Okay, so let's go ahead and add our sound files. So at the top, I'm going to create a variable, my sound. Then I'm going to use the preloader to load in that sound file. So my sound equals load sound. And we need to pass in where the sound file lives in our root directory. Luckily, it's in the same folder as the sketch.js. So all we have to do is reference the name of this file. So I'm going to reference it just by double clicking on it and copying and pasting. Going back to sketch.js and then in quotes, paste it in there. Okay. Let's go back to full screen too, so have more space to work with. Like always, you want to just test it, make sure it's loading properly. Okay, I'm not getting any errors. All right, so I think we're good so far. So the next thing we want to do is let's add this to setup. So I'm going to do background 0. And I'm going to set the volume for my sound. To be, let's do it at 50%, which is 0.5. And then my sound, I'm going to play it on load. And for draw, let's change the background to 0. Okay, so let's see if that works. Make sure that you're unmuted, and let's hit play. All right, so we got our audio file to play. Let's try and change the volume. Let's make it like 2, see if that makes a difference. So it's a little softer. There we go. Okay. And if we wanted to add some interaction to this, we could do like add a mouse press. So let's stop this. And after draw, we're going to create a function called mouse pressed. We could say, okay, my sound dot stop, my sound dot play. Okay, so I'm gonna comment out my sound dot play in setup and just do it on mouse press. So now let's play this, and then when we click the mouse, it should play. If we click it again, I think it should stop and then play again. Cool. Looks good. All right, so we got sound in. We're interacting with it by clicking the mouse down to have it play, and we're changing the volume as well. Okay, let's go ahead and stop that. So the next thing we're going to play around with is creating an instrument on key press. So here we're basically going to create a number of different variables. The ellipsis at the end just means you can continue on doing 3, 4, 5, 6, etc., however many you want. So we have to create the variables at the top. We have to load those sound files in the preload function. And then we have to set the volume in setup. We have to have a draw function here just because it's required, but we're not going to be using it really. And then we have a function key types, and we're passing in some if statements in there. It's basically saying when I press the A key, I want to play the sound 1. When I press the S key, I want to play sound 2. And you can just continue on and on and on with as many sounds as you want. Okay, so let's go ahead and go back to our editor. And I'm going to start from scratch again. So let's delete all this stuff and start from scratch. So we have our other sound files here already. So we have confetti, we have clay, we have corona, dotted spiral, and bubbles. So we're going to use those as our sounds for our instrument. So we're basically going to do the same thing we just did in the previous example, just multiple times. So I'm going to do this 5 times by loading in 5 different sound samples. And then we're going to trigger each one of those on key press. So let's create a variable at the top for S01, S02, S03, S04, and S05. So those are going to be our 5 sound samples. Then I'm going to create our function for preload. And I am going to load those sound files and apply them to the variables that we just created. So S01 equals load sound. And then we just need to pass in the names of these files. So I'm just going to click on this and copy it. It's easier to do that and more accurate rather than typing it in where I could potentially make a mistake. So I got 1. I'm just going to copy and paste that 5 times and just change S01 to 2, 3, 4, 5, and then paste in the names for each of the other ones as well. Okay, one more. Okay, so let's just check to make sure that everything's working okay. Okay, so far so good, no errors. Looks like we're okay. The next thing we want to do is create a volume for each one of these. So this is just a lot of repetition, really. So S01 set volume. Let's just set it to 1. And then I'm going to duplicate this 5 times and change 1 to 2, 3, 4, 5. Okay, looks good, no errors, got it. So the next thing we're going to do is add a function for key typed after draw. Function key typed. So this is when we're typing on a key on the keyboard, it's going to detect that and then do something. So we have to have an if statement to determine what key is being pressed. So if key is A, then we want to do something. In this case, we want to play a sound. So S01.play. Okay. So when key A is pressed, then we're going to play the first sound. So let's try that. Make sure the audio is on. Cool. When I press A, I get that confetti sound. All right. So now we just have to duplicate that 5 times and change 1 to 2, A to S, 3, A to D, 4, A to F, and 5, A to G. All right, let's try that. So A, S, D, F, G. Awesome. All right, if we wanted to make something visual to go along with this, we could do something like change the background color or something like that. So why don't we do that too, just to make it a little bit more visually stimulating. So at the top, I'm going to create a variable for C for color. And I am going to define that initially as just being black. So C equals color variable, and then 0, 0, 0 for RGB, which is black. And then I'm going to apply that C value to the background for both setup and draw. And then in key types, we can also do, okay, we want C to be color red, 25500 for when A is pressed. And we can duplicate that for S, and instead let's do green. And for D, let's do blue. And F, let's do is it red and blue? And then let's do red and green for G. Okay, let's try that. So now when I press A, I should get a red color and the sound. S, green. D, blue. F, pink, purple. G, yellow. So we could play them as an instrument now. Yay. Cool. So we made an instrument that has some sort of visual feedback as well, using sample files that we are triggering on key press. So that is an instrument on key press. The next thing we're going to play around with is FFT analysis. So taking an audio file, analyzing it, and applying it to some sort of visual interpretation. So we are creating a variable, my sound at the top again, and another variable for FFT. We're loading in the song. And then in setup, we're creating our canvas, we have a background, and then we're creating a new FFT element to analyze this audio. And then we're also doing setup and play for the audio. Once that's done, then in draw, we can take the analysis of the FFT data and then apply it to, in this case, we're going to apply it to a spectrum length. And we are going to change the number of rectangles based off of the total number of data points and change the height of each rectangle based off of each individual data point. Sounds like a lot, but it's really not that complicated. So it's better just to kind of do it and then see what it produces. So let's go back to our editor. So let's delete everything that we just did. And start from a fresh setup and fresh draw. I'm going to change the background back to 0 for both setup and draw. Okay, all right, looks good, no errors, and we're good to go. Okay, so the first thing we want to do is create our variables. So var equals my sound and FFT. Then we're going to load in our sound using the preload function. My sound equals load sound. And let's do this Marcus Calise one again. Copy and paste. Okay, looks good so far. Okay, so in setup, we are going to create our FFT object. FFT equals new p5.FFT object. We are going to add a volume to our sound. So my sound.set volume. Let's do 0.5. My sound dot play, and then there's another function called loop, which we can apply to the sound, which means it'll just loop through the audio file and never stop playing. So let's play that and see if we get some sound. All right, sounds good. So let's go into draw and let's create a variable for waveform. And set that equal to FFT.waveform. I'm going to do no fill. No fill. For our line that we're going to draw, I'm going to do a stroke color. I can make it, let's do red. Stroke weight. Let's make it pretty thick. I'm going to do 5. And then, well, first let's do a console log to see what we're getting for waveform. Let's open up the console, play. Okay, so we're just getting an array of numbers. Okay, let's see how many numbers we're getting. Dot length. So 1024 numbers. Okay, great. So that's how many times we're going to loop through this and draw a point for the wave that we're going to create. Okay, so to create anything, we're going to have to loop through it using a for loop, but we are going to be using vertex points to create this waveform. So I'm going to use begin shape and end shape, and then add vertex points in between begin and end shape using a for loop. So var I equals 0. I is less than waveform dot length I plus plus. Okay, So we are going to create another variable, var x, and we're going to map the x position for the current value, which is I, to be from 0 to waveform length to go to be between 0 and width. And then a var y, we are going to map the value of the data we're getting in waveform. So this is a value between -1 and 1. So let's do -1 and 1. And we're going to remap that to be between 0 and height. Okay, and then we can apply those values to a vertex point to draw the waveform. All right, let's see if that works. Cool. Cool, that looks pretty good. So we can also do spectrum analysis, which is slightly different from waveform. So we can do that to basically draw the height of a bar kind of bouncing up and down with the audio. So why don't I'm going to comment out the waveform for now. And let's do another one for the spectrum analysis. So I'm going to create var spectrum equals FFT.Analyze. So we're going to do rectangles, so I'm going to do no stroke. I'm going to do a fill. And then we're going to loop through the array, just like we did with waveform. Although these are going to be all positive numbers, it doesn't go between 1 and -1. It's going to be between, I think, 0 and 255. So let's create a for loop for that. Var I equals 0. I is less than spectrum dot length I plus plus. And we're going to create a variable for x and height. X is going to be similar to what we did before. We're going to map it so it goes a full width of the canvas. So I, and then originally it's 0 to spectrum dot length to go from 0 to width. Then var h is going to be mapped spectrum I between 0 and 255 to be between 0 and height. All right, and then we can draw the rectangles based off of the x position. Y is going to be 0. And then let's do width divided by spectrum dot length for the width of the bar, and then height is going to be h. All right, let's try that. Cool. So we have a similar visualization as the waveform, but it's using the bars instead and using a spectrum analysis instead. So let's see if we could combine those. I'm going to uncomment this. Again, it's command / to comment and uncomment. Let's play that. Cool. So we got them both going at the same time. Looks good. So we have the waveform, which again is between a value between -1 and 0, -1 and 1. And then we have the spectrum analysis, which is all positive numbers for this bar that's coming from the top down. We could switch that if we wanted to. Let's start it from the bottom up. So it would be height minus h if we wanted to start from the bottom up. There we go. Cool, looks good. All right. So the next thing we could play around with is linear averages. So if we wanted to average these data points rather than showing all 1024 of them, then we can do that as well. So everything stays the same setup essentially. The only thing that's going to be different is that we are going to set a variable linear average to be FFT lin averages, and we could say how much we want to average it by, and do the same thing that we did before. Just loop through that number of data points and then plot it on the canvas here. So let's go ahead and play around with that too. So I'm going to comment out waveforms, and I am going to create a variable for FFT lin for our linear average. FFT.lin average is, I could say, let's average this by 10. Okay. And then let's see if we could just change spectrum to FFT lin. See if that works. Cool. So now instead of having 1024 data points, we're averaging everything into 10 data points. All right, looks good. Okay, the next thing I want to play around with is creating an oscillator. An oscillator is making your own sound waves and changing the frequency and amplitude of those sound waves to get different pitches, so higher and lower pitches, and also different volumes or amplitude. So we're going to control the frequency and the amplitude based off of the mouse X and mouse Y position. To start, we're going to create a variable for an oscillator, and then we're going to apply that to an oscillator object. Start the oscillator, and then apply the frequency and the amplitude values to the mouse X and mouse Y locations. So frequency is probably going to be a range between 20 and, 10, 15,000. And amplitude is going to be a range between 0 and 1. Okay, let's try that. So let's go ahead and create a new document. So if you want to save that one, feel free. I'm not going to. And let's then create an oscillator. So var OSC for oscillator. And I'm also going to do FFT analysis on the oscillator so we could visually see what's going on. So I'm going to do FFT. Let's create a background. Zero. And then in setup, we are going to define our oscillator. New p5.Oscillator. And we are going to start our oscillator. I'm also going to define my FFT analysis on the oscillator. And then in draw, let's first apply our frequency and amplitude to our oscillator by applying it to the mouse X, mouse Y position. So let's do the modulation for the frequency, mod freq for the variable. Let's map that to mouse X position. Originally it's going to be 0 to width. We're going to remap that to 20 to, let's do 15,000. And then var mod amp. Let's map that to mouse Y, 0 and height to be between 0 and 1. And then we're going to apply a frequency to the oscillator using the mod frequency, that mod frequency variable we created, and we're going to map the amplitude value for the oscillator to mod amp. Okay, so let's play this. So depending on the position of your cursor, you're going to get a higher pitch and a louder sound. Okay, so that sounds cool, but why don't we visualize it as well? So let's create a waveform. So var waveform equals FFT.waveform. Okay, let's do a stroke 255. So it's going to be white. Stroke weight 5. No fill. And then we have to do begin shape and end shape. And then in between begin and end shape, we want to do our for loop to loop through all the data points. Var I equals 0. I is less than waveform.length I plus plus. And then we're going to do the same thing we just did. Loop through all those data points and apply them to a vertex point. Var x is going to equal to map I between 0 and waveform dot length to be between 0 and width. And var y is going to be equal to map the value of waveform to be between -1 and 1 to be between 0 and height. Okay, so next we have to create a vertex point and apply that x and y value to the vertex point. All right, let's try that. Cool. So the further we go to from the left to the right, the higher pitch it's going to be, and the closer those waves are going to be. And from the top to the bottom, the louder it's going to get, and the taller those waves are going to get. Cool. So that's an oscillator. So let's stop that. So the next thing and last thing I'm going to talk about is getting audio to come in through a mic. To do that, all we really have to do is to create a mic variable and apply it to the audio in object, and then just start the mic. That's pretty much it. Let's go ahead and create a new sketch for this. So I'm going to go to new. I'm not going to save this one, but feel free to save. And I'm going to create a mic. Oops. I'm going to create a variable for mic, and I'm also going to do an FFT as well, just so we can visually see something on the screen. And setup, let's do a background 0, and in draw 0 as well. And after background, let's do mic equals new p5.audio in mic.start. Gonna do a new FFT as well. And we can say FFT.set input. Our input is going to be mic. So to start the mic, all you have to do is say mic.connect. The only issue with this is that if you have your mic on and your speakers on, you're going to get a lot of feedback. So I'm actually going to mute my speakers and play this just to make sure it's working. Okay. And you probably will have to enable the mic to be able to work on this web browser, on this web page. I already did that, so I don't have to do it again. So you can see at the top that there's a little mic icon, and you can see that it's being used right now. But nothing, I'm getting no feedback, I'm not hearing anything because I'm muted. Otherwise I would get a lot of feedback and noise. So let's go ahead and stop that, and then we're going to do some FFT analysis on it so we could see some visual feedback. So let's create our waveform again. Let's create var waveform equals FFT.waveform. Okay, so stroke is white, stroke weight 5, no fill, then begin shape and end shape. Okay. And then inside of begin shape and end shape, we want to create our for loop. Var I equals 0. I is less than waveform.length I plus plus. Then create our variable for x position and do the mapping again. I 0 and waveform.length to go between 0 and width. And then var y, I'm going to map the value of waveform to go from -1 to 1 to go from 0 to height. And apply that to vertex points x and y. Okay, let's play that again. Hello, hello. Check, check, check. 1, 2, 1, 2. Is this working? It looks like it's working. That's awesome. So you got to remember that you have to have your speakers off if they're in close proximity to your mic. Otherwise, you're going to get a lot of feedback. And it might hurt your ears or burst your speakers. I don't know, but let's try and avoid that. So we have a mic working, a mic input working, and we're visualizing the audio that we're getting from that mic. Cool, looks good. Okay, let's stop that. Okay, so I just wanted to show you one more example of a project that I did that is using FFT analysis in a more, I guess, creative way rather than doing a line chart or a bar chart. You can apply those values to really anything. So you could change the color, you could change the size of something, you can change the location, etc., etc. It's just a data point, a value that you can apply to anything. So this is a very simple sketch that I created as doing FFT analysis and applying it to the size of circles rotating around the center point of an object. So I'll share this with you guys as well on the class website, as well as on the YouTube channel, so you can check it out too. So here is what it looks like. So it's basically just changing the size of these circles, these ellipses, based off of the audio that it's again based off of the audio that's analyzing from the song. And then the rotation is just a random rotation. The position is also slightly random. But it's just another example. It's an example to show you what you can do with it. Alright guys, so that's all I have for this video on audio and p5.Sound. Hopefully that was interesting, and hopefully that will inspire you to do some really cool projects around audio visualization and creating your own instruments. So again, like always, please feel free to add comments on the YouTube channel, email me directly, or Slack me if you guys have any questions or comments or thoughts or feedback. Other than that, have fun with audio and P5, and I'll talk to you guys next time.